is second unit. Already you had completed first unit and third unit. Now I will start second unit. The topic of the unit is precessional motion and gyroscopic couple. Okay, the name of the unit is precessional motion and gyroscopic couple. So first we will see the introduction. So in this introduction we will need to learn what is acceleration, what is centrifugal force, and what is centripetal force. So first, what is acceleration? Acceleration is nothing but rate of change of velocity. Acceleration is nothing but rate of change of velocity. Next one is centrifugal force. So centrifugal force means when a object is moving along a curved path. So here the force acts away from the center. Okay, so that is called centrifugal force. So centrifugal force means when a object is moving along a curved path, so the force acts towards the outwards, away from the center. Okay, centrifugal force means the force is acting away from the center. Next one is centripetal force. Centripetal force means when a body is rotating along a curved path, the force acts towards the center of rotation. Okay, towards the center of rotation. Centripetal force means when a body is rotating along a curved path, the force acts towards the center of rotation. Okay, so the differences between centrifugal force and centripetal force means in centrifugal force the force acts away from the center. Centripetal force, the force acts towards the center when a body is rotating. Okay, so that is the differences between centrifugal force and centripetal force. So now coming to the introduction. So here when a body moves along a curved path with a uniform linear velocity, a force in the direction of centripetal acceleration known as centripetal force has to be applied externally over the body so that it moves along the required curved path. This external force is known as active force. Okay, next, when a body itself moving with a uniform linear velocity along a circular path, it is subjected to centrifugal force radially outwards. Centrifugal force is called reactive force. So here active force means centripetal force, reactive force is nothing but reactive force means centrifugal force. The action of reactive or centrifugal force is to tilt to move the body along the radially outward direction. Okay, so here in this introduction we will see what is centrifugal force and what is centripetal force and what is active force and what is reactive force. Okay, centrifugal force means when a body is moving along a curved path, the force is acts extremely outwards of the center. Okay, centrifugal force is also called as reactive force. Next one is centripetal force. Centripetal force means when a body is rotating along a curved path, the force acts towards the center. Okay, that is called centripetal force. It is centripetal force is also called as active force. Okay, next, this is the gyroscopic inertia prevents the spinning top from falling the sideways. Okay, so generally gyroscopic couple means it, so here the disc is rotating, that is spinning. Spinning is nothing but rotating. Next, precessional angular motion. Okay, so here we have one derivation is also available. So first, precessional angular motion. So what is meant by precessional angular motion? Next, what are different terms used in this derivation, we will see. So here we know that the angular acceleration is the first we consider angular acceleration. So what is angular acceleration? Acceleration means rate of change of velocity. Angular acceleration means rate of change of angular velocity with respect to time. Okay, angular acceleration means rate of change of angular velocity with respect to time. It is a vector quantity and may be represented by a drawing vector diagram with the help of right hand screw. So here this is the disk. So here the disk rotating angular velocity of omega Okay, so here OX is the OX is axis of spin, OX dash is new axis of spin. Okay, so here OX is the axis of spin, OX dash is the new axis spin. Okay, here the change in angular velocity. So to see this, consider a disk is shown in figure revolving or spinning about OX. Okay, so that OX is nothing but known as axis of spin. Okay, spinning is nothing but rotating in anti-clockwise direction when seen from front with angular velocity omega in the plane right angles to the paper. So after a short interval of time, so that is, this is xr is the short interval of time, that is delta t. So short interval of time is considered as delta t. Let the disk is spinning about the new axis of OX dash. Okay, so this is the OX dash. So here it is represented in the triangle OX dash. So with the angular velocity of omega plus delta omega. Okay, so generally the axis of spin is omega, new axis of the spin is omega plus delta omega. Okay, so using right hand rule, initial angular velocity of the disk is omega is represented by OX dash. Okay, OX dash, it is shown in the figure 2. So xx dash represents as change in angular velocity in time. So here x dash, so this is the x and x dash, change in angular velocity with a time of delta t. Okay, next, the angular acceleration of the disk, this may be represented in two components. So that is, so here the derivation is solved in two parameters, parallel to OX and perpendicular to OX. So here parallel to OX means consider as OX, and perpendicular to OX. Perpendicular to OX means OX dash. Okay, so first, angular acceleration in the direction of OX, angular acceleration in the direction of OX. So this is OX, so it is parallel to OX. So consider next slide. Already this is explained. So here components parallel to OX. So parallel to OX means always we will see the triangle. Okay, so here alpha t parallel to OX is alpha t equal to xr divided by delta t, xr divided by delta t. So this is xr divided by xr, so this is xr divided by t. So why we will take t here? Change in time is considered as delta t, small change in time, that is delta t. So xr divided by delta t. So here xr can be written as or minus OX. So xr can be written as, so this is xr, so this can be written as OR minus OX. So OR minus OX equal to xr. Okay, so OR minus OX by delta t. Okay, so here we will get OR value from this triangle. Take cos theta, cos delta theta here. So cos theta equal to adjacent side by hypotenuse. So here adjacent side is OR and hypotenuse is OX dash. Take cos delta theta. Cos delta theta equal to OR opposite adjacent side and OX dash hypotenuse. Okay, then OR equal to cos delta theta OX dash. So substitute here. OR equal to OX dash cos delta theta minus OX by delta t. Okay, so already we know that OX dash equal to, from previous slides, OX dash equal to omega plus delta omega and OX equal to omega. Okay, so substitute these. So OR equal to OX dash cos delta theta minus OX is nothing but omega by delta t. So here multiply this omega with cos delta theta. So omega cos delta theta plus delta omega cos delta theta minus omega by delta t. So here cos delta theta generally stays, delta theta is very small, therefore substituting cos delta theta equal to 1. So finally alpha t equal to omega plus delta omega by minus omega by delta t. So here minus omega plus omega get cancelled. So finally we will get delta w by delta t. Okay, so take limits here. So del alpha t equal to limit delta t tends to 0, delta w by delta t. So that is equal to, so here it is differentiation dw by dt. That is alpha t. Alpha t is perpendicular to ox. We will get dw by dt. Next, component of angular acceleration in the direction of perpendicular to the ox. So perpendicular to ox means xx dash. Okay, perpendicular to ox means, we will see there, perpendicular to ox means, so here this is xx dash, change in angular velocity, xx dash perpendicular to ox. Okay, xx dash. So here perpendicular to, where it is, component of angular acceleration in the direction perpendicular to ox. So alpha c equal to rx by delta t. Okay, so rx, rx, so perpendicular position is rx dash. So this is rx dash. So rx dash, rx dash equal to ox dash cos delta theta by delta t. So how to get ox dash delta t means, from the triangle we'll take sin theta. Okay, sin theta means opposite side, xr dash by hypotenuse ox dash. So sin delta theta equal to x opposite side, x dash r by hypotenuse ox dash. So from this, x dash r equal to ox dash sin theta. Substitute this value here. So already we know that ox dash equal to omega plus delta omega into sin delta theta by delta t. Okay, multiply this omega plus delta omega with sin delta theta. So omega sin delta theta plus delta omega sin delta theta by delta t. So since here delta theta is very small, therefore substituting sin delta theta equal to delta theta, and delta omega and sin delta theta is very small, so that's why we neglect this term. Okay, so then alpha c equal to omega into delta theta plus delta omega delta theta by delta t. So finally we will get, so this term is we can neglect, double omega dot delta theta by delta t. So here we substitute limits. Okay, alpha c equal to limit delta t tends to 0, omega into delta theta by delta t, omega into d theta by dt in terms of differentiation. So finally we will get omega into omega p. So omega p is nothing but precessional angular velocity. Okay, so this term we will remember, omega p equal to d theta by dt. Therefore angular acceleration of the disk is vector xx dash. So xx dash is nothing but, we will see, xx dash equal to xx dash equal to xr plus xr dash. Okay, sum of alpha, that is sum of alpha t and alpha c. So here already we will find out alpha t and alpha c. So what we will get, that alpha c, alpha t equal to dw by dt plus alpha c. Alpha c, what is we will get here, alpha c equal to omega into d theta by dt. So dw by dt plus omega into omega p, precessional angular velocity. So here total angular acceleration of the disk is dw by dt plus omega into omega p. Okay, so this is the final equation, where d theta by dt is the angular velocity of the axis. Okay, d theta by dt is the angular velocity of the axis of spin about certain axis which is perpendicular to the plane in which the axis of spin is going to rotate. This angular velocity of the spin, that is d theta by dt. So d theta by dt is known as angular velocity of the precession and it is denoted by omega p. Okay, omega p equal to d theta by dt. Always you can remember these terms. This axis about which the axis of spin is written is known as axis of precession. The angular motion of the axis of spin about the axis of precession is known as precessional angular motion. Okay. Next, note. So the axis of precession is perpendicular to the plane in which the axis of spin is going to rotate. Next, if the angular velocity of the disk remains constant at all position of the axis of spin, that is d theta by dt is 0, thus AC is 0, alpha c is 0. So here, if the angular velocity of the disk changes the direction but remains constant in magnitude, then the angular acceleration of the disk is given by alpha c equal to omega dot d theta by dt. Already we know that d theta by dt equal to omega p. Okay. So next, the angular acceleration alpha c is known as gyroscopic couple. Okay. So when we get alpha c means the angular velocity of the disk in the direction but remains constant in magnitude. Then the angular acceleration of the disk is given by alpha c equal to omega dot d theta by dt. Okay. So that is equal to omega dot omega p. So alpha c equal to omega into omega p. That is the gyroscopic acceleration. Okay. So what is the formula for gyroscopic acceleration? Alpha c equal to omega into omega p. Okay. So here omega is nothing but angular velocity. Omega p is precessional angular velocity. Okay. Next, gyroscopic couple. Okay. Next topic is gyroscopic couple. Consider a disk is spinning. Spinning is nothing but rotating with a angular velocity of omega. So generally what are the units of angular velocity? Radians per second about the axis of spin OX in anti-clockwise direction when seen from the front, shown in figure A. Since the plane in which the disk is rotating is parallel to the YOZ, therefore it is called plane of spinning. Plane of spinning means spinning is nothing but rotating. The plane XOZ is horizontal plane and the axis of spin rotating in parallel to the horizontal plane about an axis OY. In other words, the axis of spin is said to be rotating or precessing about its axis OY. In other words, the axis of spin is said to be rotating or precessing about an axis OY which is perpendicular to both OX and OZ. It is angular velocity omega p radians per second. The horizontal plane XOZ is called plane of precession. OY is called axis of precession. Okay. So here we will see the small equation. So first consider let I equal to mass moment of inertia of the disk about OX. Okay. So next I will explain this diagram. Okay. Next, omega is the angular velocity. So angular moment of the disk equal to I into omega. Okay. Angular momentum of the disk equal to moment of inertia into angular velocity. Since the angular momentum is a vector quantity, therefore it may be represented by a vector OX shown in figure B. The axis of spin OX is rotating anti-clockwise when seen from the top about the axis OY. Let the axis OX is turned in the plane XOZ through a small angle delta theta radians to the position OX dash in time delta t seconds, assuming the angular velocity omega to be constant. The angular momentum will be now represented by a vector OX dash. Okay. So here we will see the diagram next. So here see here YOZ. So YOZ is the plane of the disk is rotating parallel to the YOZ. So here this is the Z dash Z X dash X. So X is the axis of spin, Z is the axis of reaction gyroscopic couple. So OY is the axis of precession. Okay. Next, OZ dash is the axis of active gyroscopic couple. Next, YX is the plane of active gyroscopic couple, yz is the plane of spinning, and zx is the plane of precession. Okay, here we consider one small diagram. So this is active gyroscopic couple ox dash. So this is the active gyroscopic couple and this is the reactive gyroscopic couple. So from this diagram we will see the small equation. From that diagram, change in angular momentum. So change in angular momentum ox dash minus x dash. So that is vector. So we will take vector. So xx dash equal to ox dash minus ox. So ox dot delta theta in terms of direction. Okay. So that equal to I into omega into delta theta. We will see later here.